Hello, everyone, and welcome to this episode 27 of Techcyte Pioneers in Digital Pathology webinar series. My name is Troy Bankhead. I am the VP of Marketing for Techcyte. I also run our European office. And I'm accompanied today by Shane Swenson, who is Techcyte's Chief Technology Officer. We're very happy to have him on board to talk about this topic. Today, we're going to be talking about just a small bit about who we are, Techcyte, and then we're going to go on to talk about understanding basically what on-premise means versus what SaaS-based means. And then we're going to go through a comparative analysis, and Shane will help you basically ask the right questions and cover the topics to help you decide which solution is right for you. During this webinar, feel free to send us questions via the chat feature, and our team will be able to feed them to us at the end in the Q&A section, where we will be able to answer all your questions. So really briefly, a bit about Techcyte. We've been around since 2013, and we started in of course, the human field, but we have two other verticals, the veterinarian and environmental fields, which early on not only helped finance our development of our human algorithms, but allowed us to prove out and scale our operations worldwide. And today, what we are is a very scalable AI and workflow platform for both clinical pathology and anatomic pathology. As a company, we are just approaching 140 team members. We're headquartered in Orem, Utah, and our European offices are located in Luxembourg. We are present in over 40 countries. We've got over 8,000 customers, and to date, and the number keeps growing, we have performed over 8 million AI diagnoses. As a company, we are the only unified digital pathology platform that supports both anatomic and clinical pathology workflows. On the clinical pathology side, you can see that there's a whole list of algorithms and workflows that exist today and that are being developed. And the same holds for anatomic pathology. And it's important to note that while AI is at the core of what we do, it's far from the total value add that as a company we bring. Because while the AI is necessary and a key component, it's not the only important element in being a true digital pathology platform. We've had to get really good at custom workflows, understanding the diagnostic and operational relevance of each part, from slide preparation to scanning to image acquisition to, of course, the review process and checkout of reporting. We have an entire department that's dedicated to compliance, from FDA, CE, HIPAA, GDPR, SOC 2, ISO, and others. And we also integrate into our platform third-party AI. And all of this comes together in the framework of regulatory compliance. Currently, we're for research only in the US, but we are CE marked in the EU, and we are UK CE certified. This being said, today we're here to talk about the difference between on-premise and SaaS solutions. And for that, I'd like to turn the stage over to Shane Swenson, our Chief Technical Officer for Techcyte, who will present the topic for us. Take it away.
Okay, thanks, Troy. Hi, I'm Shane. I'm the CTO here. And as a brief background, I've been in the software industry for over 25 years. And I've been working at Techcyte for over 7 years, where, again, our focus has been on SaaS delivery of AI-enabled applications targeting microscopy-based diagnostics. And so this is a journey we've been on for a long time, and we're here to share some of our learnings and some of the key comparison points between on-premise versus cloud-based SaaS solutions. So we'll start just with some definitions. On-premise software, it's a term that's grown to mean more than what it says. And so our basic definition is this is software that's installed and hosted on computers on the premises of the organization that's operating that software for their own purposes. So a vendor provides the software, but then the receiving organization, the customer, installs that, manages it, maintains it in their own IT systems. And while that's the core definition, this also tends to imply some other attributes to these applications, which is that they're typically monolithic applications installed on specific servers that have to be upgraded individually, have to always be available for the application to be available, and tend to require a certain amount of care and feeding. And we'll compare that in time to the cloud-based software as a service model. So some of the specific characteristics are that as a customer, you have full control over and responsibility for the installation, upgrade, and maintenance of these systems. If there's a fault, like a server goes down or a disk drive gets full or something like that, it's the owning organization that has to take responsibility for making those updates as well. From a security perspective, there are some advantages. You can kind of put your arms around it. It's in your premises or maybe in premises that you've leased as a customer. And again, you're responsible for providing all of the security, both the external network firewalls as well as the physical security and access to these systems. This does come with a downside, which is that, especially in the current age of new security vulnerabilities being discovered on a regular basis, it is the owning organization's responsibility to maintain patching and keep those applications up to date. And if a malicious actor were to gain entry into that network, often on-premise applications are a less fortified target against the subsequent actions of those malicious actors. From a performance standpoint, because the IT system is often local to the users that are working with those systems, this can deliver very high performance and fast response times. A flip side here is you do have, because the infrastructure is based on what you purchased, you do have to purchase for kind of the high level expectation of usage and workload, which might mean that it's underutilized much of the time and you're not gaining as much value for it. And it could mean if your workloads surge that you run into performance bottlenecks because these systems are slower to change. You'd have to buy more equipment if you wanted to upgrade. So on the pro side, it's control. You have your own physical control, both from a infrastructure standpoint and from a security standpoint. And you can tune the configuration and the build of these systems to your own specific needs, though you do have to project what those needs are going to be over time. On the con side, this does imply a larger upfront cost because you need to purchase all of this equipment and make that investment upfront and then capitalize it over time and amortize it over time. This does often mean for these complex systems like a digital pathology solution that this is a significant IT project. And so this is going to take IT staff that are responsible for that initial design and build, as well as maintenance updates, troubleshooting, handling downtime, things like that. If you find that your practice is growing or your needs are changing, this is going to require additional capital investment, additional upgrade projects in order to scale with ongoing changes in workloads. And typically with this type of deployment solution, the rate of change is slow, meaning you have something that's validated and it's working. You don't really want to make an update to it next week if you just validated it last week. And so this tends to mean that both innovation and security updates are delayed and maybe taken on a quarterly to annual update cycle, as opposed to maybe a more frequent cycle that would be preferable. So in summary, this is an on-premise approach where literally this might be on your premises or it might be in an environment that you sort of treat as on-premise, maybe a local data center or something like that you have space in. And it comes with a lot of control, but it also comes with complexity and essentially a slower timescale of change and innovation. Now, in comparison, we'll talk about software as a service or cloud-based software delivery. And in this case, the software is what we call a distributed system as opposed to monolithic, meaning it's composed of many independent parts. And the goal of this distributed system is to deliver a service or a user experience over the internet. So rather than taking responsibility for running a particular installed piece of software, when you're a customer of a software as a service solution, you're essentially taking responsibility as a user base to make use of that service as delivered to you over time. And and this allows the providers, rather than just delivering an application for local installation, uh, they are providing an on-demand service. So the release cycle is rather than delivering something, say, once a year or once a quarter, essentially it's a continuous delivery model where every day that software as a service has to be running. It has to be scaled to the current customer demand. It has to be secured and available according to today's needs. And modern software as a service vendors handle all of that as part of their delivery model. And you, as the customer, are able to take advantage of running your workloads on a daily basis. So some of the key characteristics here are essentially accessibility and flexibility. Because software as a service is conventionally delivered over the internet, anywhere that you have an internet connection is going to have access to that service by default. So that could be, again, at your place of work. If you're a multi-site organization, at each of those locations. If you allow your staff to work from home, it could be from home or when they're traveling. And so this increases their ability to access these applications and do the job that needs to be done. Now, as a trade-off, if you want to narrow down the access to your applications to only specific network locations, like say your enterprise locations, many software as a service vendors can support that model as well, where they would essentially have a filter that says, I only allow these networks to access this application for this customer. And that way you would disable the ability to connect from anywhere else on the internet, but you might enable your staff, if they're remote, to say come through a VPN, and they'd still be able to access the application. So again, there's a lot of flexibility in that. Next, software as a service systems have really matured over the last 20 years. And at this point, the expectation is high availability and high scalability. It used to be early SaaS systems when there was a rapid increase in demand, they would struggle to meet that need. At this point, modern software as a service architectures support very flexible, load-based, demand-based scalability. And so they can, if properly designed and implemented, can essentially handle any workload that you would ask of them in real time. And so they just dynamically grow and shrink in terms of the compute and storage resources they're using on an as-needed basis. This means that the vendors can deliver a pay-as-you-go model where you essentially pay for usage as opposed to paying upfront for potential usage. Again, in on-premise, you had to kind of buy what you needed and then hope you use it efficiently. In the case of software as a service, there is an option to purely pay as you go, at which point your billing is going to be directly tied to your workload, which should be tied to the value and your revenue, enabling you to match that cost to value directly. And because software as a service already has to be flexible and scalable, the ability to create regular updates in a zero downtime, essentially unnoticeable manner is again built into modern SaaS architectures. And so this means both improvements in workflows, the addition of new capabilities or integrations, and the frequent updating of security and patching all happens behind the scenes. From a regulatory and compliance standpoint, of course, you care about this happening, but your usage is not impacted by these ongoing maintenance updates. They essentially are happening transparently on a regular basis. So trade-offs here. The biggest advantages of software as a service are that they let you focus on your mission, which is to deliver value to your patients and sort of take away a lot of the responsibility of also being an IT organization, at least for these applications. And they do that through a high level of availability and access, These are systems that are designed to be on all the time. They're designed to be accessed anywhere, to be changed on an as-needed basis, so that they can keep up with the demands of both the application workloads as well as the demands of the security needs that we have for these high security workloads. Because they're ubiquitously accessible, if you wish them to be, they also enable collaboration. So if you want consultation, if you want to share with outside expertise, or vice versa, if you want to be able to deliver your services as consultations, these cloud-based internet-connected systems enable seamless collaboration and integration with other systems. Some downsides: they of course do depend on network access, because that's the mechanism by which we connect to these systems. So the good news here is modern internet connectivity is highly reliable, but that does need to be there and working for you to prosecute your cases. When it comes to scanning, scanners usually store in local storage first. So if you do have a connectivity outage, you can keep scanning, and then the scanner can catch up when connectivity is restored. Security is an interesting one. There's a meaningful need to be thoughtful about any internet connected application. And so when we talk about software as a service security, that is real. On the other hand, the availability of rapid patching means that most software as a service systems are kept up to date with security patching on very tight timelines that usually are way ahead of what a typical on-premise installation will be. Also, modern SaaS architectures have defense in depth through a series of layers of essentially application firewalls and application gateways, just like you put firewalls around your enterprise networks to protect them from malicious actors on the internet. Software as a service systems do the same thing. And so the expectation of a very secure system in modern SaaS is totally reasonable, and typically outweighs the security of an on-premise system that's under typical maintenance cycles. Another potential con with SaaS systems and cloud-based systems in general are potentially regulatory or jurisdictional requirements about data residency and processing location. And again, this is one where you need to look pretty carefully at the regulations and look at the cloud vendors that are available in your jurisdictions to see if there's a match there or not. Often there are valid pathways to use cloud systems, even in highly regulated environments, like healthcare environments, as long as the right security controls are in place. And the good news here is that the cloud vendors and the SaaS providers, of course, understand that and have the appropriate compliance controls available to enable those to be fully compliant. So in summary, when we look at SaaS, software as a service, we're really looking at a shift towards agility and availability, scalability, while maintaining security and cost effectiveness. So the goal here is that this really does provide kind of the best user experience, the best patient value, and the best value to your business as well. This includes access to the ever-changing field of AI algorithms and connectivity between those systems as needed, collaboration across multiple sites and locations, as well as consultation, which can then bring more expertise to bear on your critical cases, and provide better outcomes for your patients, as well as a more efficient experience for your pathologists. If you're looking to stay at the forefront of digital pathology, which from our perspective, it's just getting going with good slide scanners and good IMSs, and now these more integrated platforms that can bring valuable AI into these workflows, then software as a service is going to provide a more up-to-date model to enable those more powerful workloads and over time. And so in the end, it's a choice of, in this case, taking that agility and flexibility over maybe the more static installation associated with an on-premise solution. So now let's look a little bit at some comparisons. So first one, if we talk about performance, software as a service solutions are very highly performant. They have access to entire data centers worth of compute, storage, and network. They enable continuous optimization to deliver a better experience over time, and they're very highly available. In the case of an on-premise solution, the performance is going to be dependent on what equipment is available in that on-premise installation. And if the workload demand exceeds what that system is designed to provide, it's going to have a direct impact on performance. And as future, maybe higher demand workloads become available, maybe newer AI models, for example, and newer algorithms, that on-premise system may struggle to deliver those new workloads efficiently. Similarly, flexibility is, of course, limited by capital update cycles, maintenance windows, and installation timelines. And this all requires active work by the IT team that's supporting the application in an on-premise environment. Looking towards scalability, we kind of touched on this. Bluntly, the cloud is huge and can scale to handle any reasonable workload that you're going to be able to bring to it. And so, again, it's worth talking with your vendor about, are there any limits to how large of a workload you could process on their system? But well-designed software as a service should really be able to handle your workloads. And geographic scalability, if you're multi-regional, of course you can scale in that direction as well. Whereas an on-premise, your scale is again limited by what you could afford to install and maintain. And as far as geographic constraints go, again, you might have to network between your locations and access a common data center, or you have to replicate your systems to each of those locations if you have multi-site geographic scalability. Security, this is one we think about a lot right now because the AI-enabled security research and exploitation tools have become extremely effective. And so we all should be thinking about security in our daily and professional lives. And from a software as a service perspective, this means we stay up to date on patching, and all good software as a service vendors should be doing this. They should be making very frequent updates to their software and to the software they depend on to make sure it's secure against the most recent emerging threats. In an on-premises system, update cycles are often more expensive. They might require downtime. They might require off hours, maintenance windows. And so there tends to be a hesitation to make those updates as frequently. When it comes to the good compliance side, your SaaS vendors should be your close partner in compliance. They are going to be responsible for a lot of your controls, and they should be transparent about how they're meeting those requirements and implementing those controls. In the case of an on-premise solution, you're going to be responsible for those things yourself. And then from a data security and integrity standpoint, any compliant software, cloud-based software as a service solution is going to encrypt all data in transit, all data at rest. It's going to create a multitude of backups of that data so that you have integrity and disaster recovery options. On the other hand, if you're running an on-premise solution, you're responsible for those backups, and you're responsible for assessing how to bring those backups off-site so that if you have like a local emergency that compromises one location, you have like a physical problem with a data center, to make sure you still have the data that you're required to keep from a compliance standpoint. In the case of software as a service, multi-site distributed backups are the norm. And it's still important to ask about this when you're evaluating vendors, but I would expect they would all have a good answer to this that ensures the integrity of your data over time. Now, cost is an interesting one. So most software as a service enables a pay-as-you-go model, and you can often prepay for a discount, but fundamentally the usage-based pricing still applies in most cases, where the more you use, the more you're going to consume of that prepayment. It does not require an upfront payment or upfront installation of additional hardware. to make use of a software as a service solution. So a very low investment can then be leveraged into an immediate turnaround of of usage, and this should result in a lower need for your local IT staff to engage as well. Like, again, you're still going to want to evaluate the fitness of these solutions for your your clinical needs, for your business needs, for your regulatory and compliance needs. So that requires some expertise, but less expertise than it would require to actually install and maintain an on-premise solution. On the on-premise side, for cost, of course, there's an upfront investment required to build and enable these solutions, and because you have to pay that full upfront cost, if your utilization is less than the full capacity of that system, your actual true cost of ownership per case that you're signing out could actually be higher than that pay-as-you-go model on the SaaS side. If you get perfect utilization, often buying your own equipment looks cheaper on paper, but you do also need to add all these other true cost of ownership factors, including maintenance and managing it yourselves. So speaking of maintenance, in the case of software as a service, the vendor is responsible for this. They are making the updates on an as-needed basis. The good services that are running kind of modern practices are making those updates daily or faster. And again, they should be totally transparent to you. There should be very rare required downtime for maintenance, because these software architectures are designed to be fault tolerant and resilient and what's called elastic, meaning they can scale with need. And so doing an installation just means adding new servers and then taking down the old ones transparently. Also, from an integration standpoint, whether it's integration with other cloud-based vendors or integration with your on-premise systems, again, those can be integrated and updated on an as-needed basis. When you look at maintenance of on-premise systems, of course, you're responsible for doing this internally, which often means scheduled downtime, taking the application down, making a set of updates, bringing it back up, validating it, and then proceeding. And this becomes a complex source of additional mindshare and additional personnel in the organization performing these updates. From an innovation standpoint, software as a service, again, because there are updates taking place all the time, because this is essentially a low cost and just part of doing business practice for the vendor, you're going to have access to faster updates and newer capabilities, newer workflows in a SaaS model than you are with an on-premise model. On the other hand, if you don't value that type of update and you prefer to stick with something that's just known and well understood, then the on-premise model can provide that. But it does come with, again, being a static implementation. It's going to be fixed in terms of what it can do over time. So with that, what's the right solution for you, and what are some questions you should ask? Partly it's a question of, do you value being able to have sort of a low barrier to entry and the ability to scale with demand and to evolve with changing workloads over time, including new AI workflows that are coming out all the time as well. That's going to point more towards SaaS. If more of a fixed set of capabilities is all that's really important, SaaS can, of course, provide that, but so can on-premise. From a security standpoint, I think it's worth taking this one very seriously and thinking carefully about it. Again, SaaS vendors and the cloud vendors that they rely on have security as top of mind every day. As a clinical practice, it's something that, of course, you have to be thinking about, but you have to ask, is this something that you and your team want to be thinking about every day, or is this something that you'd like to have outside expertise handling for you? If you've got a robust security solution, then on-premise can be an option. But if you're not able to keep up with that, it becomes a liability. And then as far as data location and processing goes, again, modern cloud-based infrastructure vendors have presence around the world. And so they very likely have a presence in a jurisdiction that's acceptable to you. we're based in the US, but we also have presence in the EU and are able to do so in other jurisdictions as needed. And most SaaS vendors would be the same. And so you may have regulatory restrictions that say it has to be in a particular location, but it may be that there's actually a path to the cloud. Most of the jurisdictions we've looked at do have valid cloud-based options available to them. So again, this is something that needs to be solved, but it doesn't have to be a blocker for using a software as a service solution. So with that, we'll just again tell you from our perspective, we take our responsibility for delivering secure, reliable, available software as a service very seriously. And that includes partnering on the compliance side. We, of course, have our own compliance that we have to maintain, but we also work with all of our customers to help them maintain their compliance as well, because it does look different when you're using a service as opposed to a fixed software stack. With that, go to questions.
Thanks very much for that presentation, Shane. We've got several questions actually coming in from the audience. Alexa has asked, what bandwidth or network requirements should a lab plan for before adopting cloud-based digital pathology?
Yeah, that's a great question, because of course the connectivity is essential. This totally depends on your workloads and your scale. So our recommended minimum for a very small lab that has a very low processing rate would be 10 megabits bidirectional, which is actually quite low in today's infrastructure. For a more enterprise experience, we look at 100 megabits bidirectional or better. And for very large, like reference lab size implementations, we work with you because your bandwidth requirement will actually be quite a bit higher than that. And you can essentially do some additional like direct connection options to make those as efficient as you need them to be.
Another question, Mike asked, how does data residency work if a lab operates across multiple regions or countries?
Yeah, and again, this actually comes back to your own compliance needs as well. In the case of the US, multiple regions in the US are considered equivalent. In the EU, where you may have separate countries, you'll have to look and see, do your country level regulations enable reciprocity with other countries, or do you have to stay in country? And so it's sort of easier if it can be regional as opposed to like per country, but either model can work. It's just a question of how many instances of your data store and processing will be required to be set up by the SaaS vendor, and what type of interconnectivity will you be able to enable. So again, that's going to end up being a case-by-case answer.
Indeed. We've got a good question from Jay. He asks, how do you recommend getting our enterprise IT group to at least explore these different deployment models? They're currently so ingrained with our PACS, which is on-premise, and thus far have refused to explore anything beyond the PACS Digipath model, that it's super cumbersome and not designed with pathologists in mind at all.
Yeah, that's a good one. And I've seen this, we've seen this as well. It can be, change management is difficult, and this is a new way of performing these clinical diagnostic workflows, but this is not necessarily a new way of performing other types of IT functions. And so one thing we found when we talk with IT departments is yes, their clinical applications they're used to running in an environment they've configured for on-premise usage, but many of the applications that they're using for their daily work are actually cloud-based, SaaS-driven. And when we have those conversations and we talk with them about the trade-offs of those SaaS applications that they're already using, and we ask them, well, how do you feel about data security? How do you feel about availability? How do you feel about cost? How do you feel about the agility and collaboration that it enables? And you start to sometimes get some head nodding and like, oh yeah, actually, we really like that for our applications. And we say, okay, let's talk about your pathologists. Let's talk about your technologists, and their needs are actually quite similar. Let's find, if there is one, a safe, reliable, appropriate way to enable them to have that same experience. And sometimes that's been able to open a door to at least look at piloting. Another pathway that we found has been, if you can find an application that's relatively low stakes, and ideally one that can be executed without PHI. And for example, some of our clinical pathology systems, like a fecal oviparasite read, don't need any patient information as long as you have some type of linkage, like in a barcode that is scrubbed of patient information. And then we can talk about, look, from a security standpoint, you're not uploading PHI to the cloud. You're just uploading the high resolution microscopy image, and there's nothing identifiable about it. It's considered a very low risk piece of information. Let's start there where the stakes are lower, but the benefits are significant. And if we're successful there, then we can start to look at our higher risk workloads over time.
Thanks for that. Yogesh has asked, what are your thoughts on a hybrid model? Hot on-site, and I assume we're talking about storage and treatment. Hot on-site, cold and archival on the cloud.
It's interesting. We actually see both hybrid models. So the advantage of hot on-site would be local access, and so you would expect great performance. And then the cloud as a trusted partner for a long-term archive with high data resilience because of the backup solution that they provide. And we've seen some looking at that model. And what we've been working on is to try and make it so that the cloud-based performance and user experience is equivalent to an on-premise based user experience. And we've had some success with that. We're actually really happy about where we've gotten with our pathology viewer. And so at that point, that starts to mitigate the advantage of the on-prem solution, and you gain the benefits of the flexibility and scalability and ubiquitous accessibility of the cloud. The other thing we have seen is we've seen some who say, I want to use a cloud-based solution for my active caseload, but my archive, I want to, I never plan to look at these archive slides ever again, but I have a compliance requirement to save them. So can I literally get a tape drive that writes them to tape, and then I put the tape in a vault somewhere? So a very low cost, sort of inaccessible archive, but one that could potentially meet compliance. So we've actually seen both hybrid models, and I'd say it depends on the trade-offs that are important to you, but they are reasonable architectures to explore beyond a pure on-prem or a pure cloud-based model.
Thanks. We're a bit over time, but I did want to address one question we had. And I'm sorry if I mispronounce your name. Mariah has asked, for roughly 100 slides per day, is cloud SaaS suitable or needed?
I think it's totally suitable. We have customers that process ones to tens of slides per day. We have customers that process thousands to tens of thousands of slides per day. And they all get great performance. They all get essentially their usage-based pricing. So they're actually paying a fair price based on their workload. So I think SaaS would be a great solution for that. On-prem would work as well. Certainly that's a scale you could handle with on-prem, but if your workload changed dramatically, again, you would need an upgrade. Whereas if you're in the cloud and your workload changes, it'll handle that with no problem.
Yeah, and
I'll just go ahead.
And at that 500 slides per day, that's a volume that would certainly benefit from the kind of business model that comes with SaaS, whereas there's no fixed software licenses. You just pay per use. And so it's completely adaptable.
Yeah. And I saw just the question about if you use a VPN from home, does it slow down image viewing? I'll say it could impact image viewing because it's requiring all your network traffic to take additional hops out to your VPN server and then to the SaaS provider. If you have fast internet, if the VPN is fast, if the enterprise you're going through is fast, it's still going to be okay. But it could be a bottleneck if not.
To access our platform, we don't require VPN. It's just over a secured HTTP protocol for all of the user interaction. Well, that brings us to time. I'd like to thank everyone who's joined us today, and especially to Shane for walking us through the topic. The on-premise versus SaaS choice is a real one, and every lab will weigh it differently. We built Fusion in the cloud for a reason, and if you want to talk through what it could look like for your lab, get in touch with sales@techcyte.com. We'd love to talk with you. Thanks again, and take care, everybody. Bye-bye.
Bye-bye.